the next generation firewall also wants to finalize it out. And my partner is, they did an excellent speech, the same place a couple weeks earlier. So we work together, try to bridge our domain between the security and the car industry, and then work together to find some better way to defend the auto threats. So here's a picture about my prediction in 2012. I mean, this figure shows the time point where it marked by the yellow color. And so afterward, we'll see more and more botnet activities. And I would predict it could be like mobile rookies. In early 2014, there's a new rookies called Outbox data discovered. Then currently we have seen more and more mobile malwares. So I'm pretty happy because the most part already happened, became reactive. So anyone know what the big difference between the mobile and the PC? Any big difference?
Small.
Anything else? So for the mobile, you can bring to anywhere. So actually, the hacker just saying mobile is not like an infection target. Instead, it's just like a spreading channel. For example, if you bring the mobile into your enterprise, the IT guys probably apply BYOD, bring your own device policy, to make sure there are no enterprise data leakage from your mobile device. But just assume if you enter the car, so the car have embedded Wi-Fi and you mobile have Wi-Fi, they have communicate. So you can get the data out of the auto. But at the same time, you can inject some commands into the car. So you might say the pie chart, there are 3 sectors. One sector in blue color is called malware, because many security vendors in this space, they're very cloudy. Unfortunately, the sector in red color is some price leakage. And like 6 million apps, they have issues with price leakage. So these apps will be related to the new emerging market, which is like connected cars as well as wearable device, because we have hardware, OBD box, and wearable watches, but you have also the apps on the mobile device that communicate. You also have cloud, collect data, and do some data analytics. So we focus on not only for blue collar, but for red collar. So the new prediction this year, we're saying like emerging market, it became more popular, and we focus on the smart car tonight and try to go through what we have done for the past few months.
Okay, so how many of you have a mobile app on your mobile device that you use with your car? In other words, use it like for navigation, use it for finding gas. Okay, probably most of you. I know I've got a number of them I use in my car. And that whole aspect is growing. And what I was just telling you is that when you bring a device in your car, you need to know that the app you're using on your device is going to be secure, and it's not going to be capturing data off your car that it might be transmitting to others and selling data off your car to others, or telling people about how fast you were driving over your car. So some of those are some of the kind of things you have to worry about. As we look here, the logos on the left of the screen are those manufacturers who have now signed up and will be offering in future models. Ferrari's already introduced one using the iOS CarPlay, and the ones over here on the right are makers that are signed up to do the Android auto integration, and then the ones in the middle have signed up to do both. So this is not going to get smaller, it's going to get bigger. And as these integrations into the cars bring more and more apps in, the concern about security, both things coming into your car and things going out of your car, it increases. Now, probably nobody has a problem with security in their car because of their apps today, but you never know. Question.
So I'm just curious, how about QNX?
QNX, yeah, good one. QNX, for those who don't know, QNX is a operating system that was developed originally by QNX and bought by RIM, BlackBerry. And most cars' head units that have entertainment-based head units and navigation use QNX. It's by far the largest segment of the operating system market in a minute. And I think QNX is going to remain. These things are going to kind of ride on top of it as an integration for functionality. QNX may end up being a player in this, although QNX may end up being displaced by decisions that are made about higher and higher mobile integration, maybe using an Android-based operating system or iOS-based for doing more things. But as yet, they're all going to kind of coexist. But there's been no publicity or direct work that I'm aware of in making QNX become a player in these two mobile integrations. Is there another question? Okay. Here's an example of somebody already hacking CarPlay. You take a dash and you make a special bracket, you slide an iPad in, and bingo, you got an iPhone connected to your iPad, and the iPad can remotely connect by Wi-Fi to the OBD2, and you've got a $100 integration of iOS CarPlay. It seems silly, but guess what? There's a whole bunch of people out there that have already mounted iPads in their car somehow, and they really want to get that app functionality in their car. And it's going to happen. And in the process, everybody gets exposed to the vulnerabilities of the system.
Actually, it says very well.
So, for example, I just threw out, these are just a few of the apps. There's literally hundreds, if not thousands of apps that you might have on your mobile device that you can easily use and perhaps want to use in your car. Certainly, music and media, I think satellite radio is, for all intents and purposes, dead. If you try to use Pandora in your car, the experience is far better than satellite radio going under an overpass when it cuts out and stuff. The Pandora seems to work perfectly. It's free. You're not paying a monthly subscription for it. And the audio quality is better. So there's a lot of players competing for the audio media players. Spotify, Pandora, iHeartRadio, RDO, all of this. So there's going to be a lot of opportunity for media-related apps to bring things into your car. Mapping and navigation. If any of you have used Waze, Waze is my personal favorite. It's got a great social media component. It has the most up-to-date real-time traffic reports from everybody that's out there driving around, telling everybody else what's going on the road. But even so, all the others, many of which are free or some which are very inexpensive, cost way less than a multi-$1,000 OEM navigation system. So car companies recognize that and are increasingly allowing people to bring these kind of apps into the car through those collaborations like CarPlay and Android Auto. Social media. I know you shouldn't be texting and doing that stuff when you're driving, but you can if you do it with your voice. And there's a number of things coming. Some companies I'm working with are working on, and some that already exist, which will allow you to, log on to Facebook and hear your recent posts or post something on Facebook with your voice while you're driving. Check in on Foursquare, Yelp, do mobile tweeting with your voice. That's all going to happen very shortly. If it isn't already. And then there's lots of other services you might want to use in your car. Fandango, seeing where the movie is, buying a ticket, checking the weather, looking up a search for something you're looking for, shopping, many things like that. And then there's all sorts of apps related just to driving. INRIX is a traffic cam app. Miles, mileage finder, whatever it is, keeps track of your mileage for business and personal use. A bunch of apps here for performance-oriented stuff, reporting how your car's running, measuring your quarter mile times, measuring the G's as you corner, all kinds stuff like that. Escort has a social media radar detector app, so other people's radar detectors go off. It goes into a network and it pops up in your car if you've got the Escort app, so you'll see where other people's radar detectors went off before you even get there. HUDway is one that gives you a heads-up display using your phone that projects the image on your windshield, and you can get a little bit of a speedometer and that, like a multi-$1,000 feature in some high-end cars. You can get a heads-up display. Glimpse, if you activate Glimpse, it'll send an email or a text to someone you know with your current location, and they can follow you for as long as you set, maybe 30 minutes or an hour. They can keep track of where you are and see what you're doing. Things like gas buddy, where you find gas. Emergency radio is basically a police scanner. Automatic is a startup. It's got a lot of press. It kind of does scan tool stuff, but it also watches how you're driving, how fast you're pressing the accelerator pedal and releasing it, how hard you're braking, how fast you corner, and then gives you guidance on how you can drive better and get better mileage. So it's got some interesting features. And then a bunch of others like Uber, where if you can turn your car into a rental or a limousine, and you can make a little extra money and take people for rides. So lots and lots of apps, and again, many of these are connecting directly to your car through some devices we'll talk about in a few minutes here, and that pathway is now bi-directional. So things can be coming into your car, and data can be coming out of your car, and you probably want to know what that is so you can control what and drive. So I think the next one is yours.
We enjoy the mobile apps, and don't forget the problem security issues. So we pick up apps from the slide before, and we do some reverse engineering. For example, with Angel, the APK file, we do reverse engineering from all the tables and just plain text without any encryption. So you can easily get all the car sys numbers, the driver information, it goes through all the tables, car information, your friend, driver profile, so all just embedded into the apps. Just be careful. We use this mobile apps to make sure that no people were collecting the value of awareness. So we have like car app security audit preferred. Whenever you submit apps within like 15 seconds, I will give you like the audit checkup. So for example, we have 4 categories. For each category, from like data leakage to this check mark or just no good. For example, also like security, any system or encryption, or any like possibility for mail attack. So there's also the pie chart for one example show what percentage for the data leakage, any like data message monitoring or file operation. We go through like more than 40 of the apps, and here to show the total risk score from 0 to 100. I mean, 100 is the worst score. We also give you the full categories, how many percent behaviors, so you can see all the pie charts based on mapping to this table. Yeah, for the auto security, starting from 2010 and 2011, there are 2 research papers from University of Washington and UCSD. They did a very interesting experiment by injecting some OBD commands into the OBD port. So Charles and Chris also did a lot of work starting from the second round of 2013 until now. Next week we're gonna give you a presentation on Black Hat as well as DEFCON about the hardware device. Similar what I'm doing, but using a different approach. This month I make a presentation in Beijing about our demo about the CAN-bus firewall. So all the attack scenario based on the OBD port. So this is the chart about auto security vector. For example, for the car rentals, we have a cloud managed portal send the command to the car. So for if you're owner, you try to rent a car to somebody else, just leave the car inside. Then the rent company will give you mobile apps using button, open the door. So the stroke the order, then you can get a key and drive away. So, but also like a lot of apps, just besides be using CarPlay or Android Auto, they also could be have communication between OBD. They might send like commands into the car. They also have problem with driving slippage. And when you're driving, you just put the button on the panel, they might distract you from driving. There are also some issues where sleep driving.
Okay, so well, why doesn't the car companies think about this, right, and fix this before it happens? Well, the problem is, we talked about this when I gave the other pitch, is that car companies are very deliberate. It takes them a long time to develop, qualify, approve, resource, and do these things. So the typical lead time is a 3 to 5 year window from, let's say we started today, it's 5 years down the road before you can actually buy a car at showroom that has the feature we started talking about today. So it's going to take them a while to do it. We think they're interested in this. They certainly are concerned about it. But you'll see an increasing amount of security coming into the car. Currently, the CAN bus that's accessible via what we call OBD2, which stands for Onboard Diagnostics. It's the plug that's under the dash of all your cars that's there by law, is the main access port for dealers and service technicians to access your car and service it. But that's also a port for many of the systems that are in the car and things we're talking about. So securing that port is important. It has absolutely no security on it at the moment. Anyone can go on there with any of the tools we brought today and gain some level of access, if not complete access, to everything in the car. So that's why there's a concern.
Question.
Yeah.
So, is the OBD2 port, which is typically under the dash,
Yeah.
is the only interface to the vehicle bus, or there is another?
It's not always. In many cases, it's the only one. In other cases, there may be other specialized diagnostic ports, perhaps for like an anti-lock brake module or airbag module. But everything is accessible through the OBD port. It was mandated, actually started in California, the California Air Resources Board, and the purpose was to allow emissions testing stations to connect to the car and quickly get information like the ignition advance timing and the RPMs and the parameters of the engine. It has evolved to now kind of the de facto standard of how people interface with the car and diagnose it. So all of the tools that technicians in the dealerships and private repair shops use all connect to the cars through this port. And again, it's known as OBD2. The pinout is standardized, but you'll find from car to car there may be some variations. For example, pins, I think it's 16 and 4 have been assigned for CAN bus, but my car turns out it has 3 CAN buses. So there's a CAN bus on 16 and 4, and there's 2 other CAN buses on 4 of the other pins. So yeah, there's some PID changes sometimes you have to do for diagnostic tools to make it work on that particular product. So also real quickly, I brought a couple examples of breakout boxes here. This is the plug that goes into the connector on the car. By law, it has to be within 6 inches of the steering column. So if you go into your car and you can't find it, don't go any further than about 6 inches away from the steering column, and you'll usually find it. And then this is a list of all of the circuits that are called for in the OBD2 port and on your CAN bus and other communication bus lines, as well as other things, grounds and power and so forth. This box happens to be a forensically neutral box. It's just wires going to sockets. There's no electronics in here at all. There's also boxes you can buy that have a voltmeter, have LEDs that tell you whether data is transmitting on the line or whatever. Those are also useful. They're not useful in forensic investigations, though, because they might introduce some other stuff. But all this stuff is really available. The box, all it does is provides easy access for you to get to these things. You plug this port in, and now you can plug your own test leads and whatever into the box and whatever circuit you want.
So electrical.
Yeah, electrical, yes. Yeah.
And these are digital, right? 0, 1 or.
No, some are analog. Some are analog. Okay, so what's behind the OBD2 system? Here you can see kind of a general diagram. So the port was originally meant to go to the engine controller to send information for emission testing. But today, it might go through several gateways. Go to the engine control, go to chassis controller, go to airbag, go to your infotainment system, go to your comfort convenience systems, and then other networks like your remote keyless entry network. We have one more. So for example, this is a diagnostic cable for Toyota, Lexus, and Scion. Factory authorized. This is what the dealerships use when they test your Toyota, Lexus, or Scion. Just to a USB port. This and Volvo currently are the only two companies that also, through this interface, also can reprogram any of the computers in your car. So it can update calibration in your engine control, it can send new software to your head unit, it can change how your instruments work. But this is the direction the car companies are going. Currently, if you want to reprogram other cars, you also plug into that port, but you need a different box to do that. More and more car companies will have a cable that other people can get their hands on. They can actually go in and change the software in your car, and that's how they update the software in your car if you take it into the dealership for a software update. So it's an easy process. The problem is it's a little bit too open, and perhaps people go in there that shouldn't be. So again, the reason for security concern on the car bus. And again, all these systems are connected. This port became mandated in 1996 model year, so all cars since 1996 have it. Right around 2008 model year, they went from a very slow network protocol, we call it KNL lines, to CAN bus. And CAN bus is faster now and also provides access to more things in the car. So anything that's later than 2008, you can be pretty sure it has a CAN bus and it's access to all those systems. Okay, so there are other communication buses in the car, and those are also unsecured. But again, if you're going into a modern car, you're probably going to go into the CAN bus, and you can access signals that come in. So, for example, your car has an individual wheel sensor at each of the four wheels that are used by the ABS in-line brake system to figure out how fast the wheels are turning. At any given time, all four of your wheels are not going the same speed. They're all going slightly different speeds. You can turn one way, turn the other. So how do you report the speed? You got a speedometer, right? It's reporting a number. Various things in the car need to know speed. The engine control needs to know it. The electric brake system needs to know it. The airbag system needs to know it. Your radio sometimes needs to know it because you have radios that vary the volume of the speed you're going. So those wheel sensors wire directly into the anti-lock brake module. The anti-lock brake module processes those four different speeds and then aggregates it and creates a number that's called vehicle speed. That's the speed it says, that's going that fast, going 50 miles an hour. It then sends 50 miles an hour out on a CAN bus message that has an identifier as vehicle speed. And then it goes to all the modules in the car. And all the modules that need to know speed, then get that number and read it and think everything's fine. But what happens if, for some reason, that number is corrupted and you're going 30 miles an hour and you have the cruise control set for 60 miles an hour, it's now going to apply the cruise control full tilt until it brings the car up to 30 miles an hour to 60. So it is a security-related and a safety-related concern that all that data is accurate and protected and has the right priorities associated with it. So, cars have gotten pretty complicated, and they're, in fact, computer networks, as you can see. So, back to one.
some kind of access which you can remotely control.
Well, okay, that's sort of true, yeah. Actually, the wires, CAN bus wires, are twisted pair, and they go all around the car, and you can access them anywhere you can find them, okay? You don't have to get them there, but you can certainly easily get them there. But when you connect a wireless dongle, like a automatic app uses, or a Uber car that has a dongle that has a 4G link, so you can use your phone to open the car, you've just created a link to the outside world that can get access to the CAN bus. So. 2 more. Okay, 2 more. 2 more. Okay.
So like the yaw sensors and the G sensors, like in cars like the Nissan GTR and stuff like that, are they connected to the ECU or are they connected to the CAN?
Usually the yaw sensors and the G sensors are part of either the ABS or the stability control. In many cases, those are combined into one unit. And they're usually physically mounted in that unit. There's also a G sensor for the airbag, a 2-axis G sensor, and that's usually mounted on the center hump of the center console. They try to put that into the center of gravity of the car, so it gets most accurate reading. But yes, those values are published on the CAN bus.
What is R sensor? What G sensor? I know. What is the other?
Yaw sensor. Yaw is the tilt.
Yeah.
Tilt angle.
Okay. Oh, 2 more. Oh, okay.
So the CAN bus format. There's basically 2 basic formats. One is a standard CAN bus, which is an 11-bit identifier, and then the extended CAN, which is a longer identifier for sending more data, basically. So basically what it does is it sends an identifier, and the identifier includes a number that's interpreted as a priority. So the highest priority messages are those related to safety or reliable operation of the engine and all the systems that need to know right now, urgent messages. And so they get the highest priority. And then less important messages like turning down the temperature on the climate control 2 degrees is a lower priority. So the high priority messages might bump other messages off for a while. And the paper that he alluded to with at the DEF CON before, where these guys took a Prius and they took a earlier Model 4 Escape, both of which had automatic parking systems that are connected to the CAN bus. And so they hacked into those 2 cars and proved that they could sit there on a laptop in the back seat while somebody drove. They could yank the steering wheel out of the driver's hand. And there's videos showing that. They can enable or disable the brakes. They can enable or disable the throttle. They could take over the operation of the car just by the twisted pair of wires in there. The concern was that no one would ever do that. Well, it could be done, and it can.
Is that going to work authentically?
We have to ask why. I think the answer is yes. It's definitely not worth attending.
Yeah. But right now the flight the ticket is very expensive. I pay like $250 one trip.
So there will be a follow-up they're doing, and they're releasing a firewall sort of device, as what is going to show here in a little bit too. But anyway, so yeah, as you think about cars going forward to autonomous cars, they're still using CAN bus stuff for all intents and purposes. So if you could hack into a Google car driving around by knowing it's got a little Wi-Fi connection that might get you in the CAN bus, you could program it to stop and pick you up, take you to McDonald's. So, we know what people might do, especially guys like you that are in this room. So anyway, back to you. The cables. So some of you stopped up here, and afterwards, if you're interested, I brought a selection of diagnostic tools and various interfaces for the OBD2 port. Some are Wi-Fi, some are Bluetooth. They're all used for diagnostic and accessory products today. Also brought along a scope, which shows how you can read the scope on the CAN bus. You saw the slide that earlier on that, or we'll show it to you in a bit. And also a tool for logging data off the CAN bus. pretty easy to do.
One more question. What's the ECU simulator?
Oh, well, ECU simulator, it simulates all the signals that are running in your critical computer. So it's things like spark plugs, injectors, engine speed, crankshaft speed, camshaft speed, temperature. So you can, there are boxes you can buy that are simulators so you can test apps and test things you're developing without actually having to put them on a real car and drive it around.
I'm going to take this page to a brand and just take it. So how we get the data from autos here, like the scripts. So this script is not as difficult as this one, because if you understand what the frame format you were, for them to choose the ISO, this protocols, and you can say, okay, I only want to monitor pin ID beginning with 7. So here you just mark those wire part here. So all information comes from auto beginning with 7. So you just regular ISO auto switch, you can get data from auto. So this how you connect with OBD, with cables, converter into the laptop, a bunch of software you can download from the internet and do this kind of things. So,
Yeah. So we did this on my car a week or two ago. This is looking at the CAN bus with scope. And the scope also decodes the data, so you can see some data decoding below here. This is on a 2013 Ford Escape, and you'll see the blue trace is CAN low, and the red trace is CAN high. So there's two signals, two wires, one's CAN low, one's CAN high, and they're always complementary. So you'll always see the same signal on the highest side as you go on the low side, except for their energy. And that is for integrity of the signal. So if they get mixed up or off, then you don't get CAN data. They both got to be together. And they're both referenced to ground. So those are two separate channels going into the scope. They travel around the car in a twisted pair, and they're terminated with it's something like 160 ohms at both ends of the network. And that has to be correct. If not, then the CAN bus signals don't get interpreted. So it's a simple network, and it's inexpensive, and that's how we transfer it. So here you see just basically two frames. There is some data collected in the frames that it sees. I've got another example hooked up here right now. And so that's how we did it. Just went onto the OBD2 port, went to the CAN high, CAN low with the scope, and you can see it.
Let's go back to reverse linearity. This is restoration package from.
So that scanning tool you used picoscope.
Picoscope, there's a scope, not a scan tool, but yeah, picoscope was used to show the signal and some decoding. But he's using a tool much like this one. This is called a Kawasa Leaf. It's a USB to CAN bus. So this is where the CAN bus goes into this side. Here I just made a little breakout box for CAN high, CAN low, and low. And then you can collect data like you see here. And some software to run on PC.
Yeah, you can give like a diagnostic elements IDs versus numbers from the binary editors. You can a lot of software you can choose from. So you're from the far by reverse engineering, you will know what the receiver's can ID. This probably can be supported by diagnostic software. So you can see the receivers, their send IDs, but also some information about ECU parameters. You go through all the way from here.
So what they were doing in their example, they were trying to capture certain commands from the car. So the way you do it is you hook that up, and it just runs continuously, right? The CAN bus is always sending data. So you collect a bunch of data, and you operate the device you're trying to detect. And then you go back and you look for that code prefix appearing in that must be it. Then you go back and send that code in on your, with your laptop yourself, and that unlocks the door. You found the code.
We found that fuzzy reversibility.
So the XML is shown here. Is it based on some kind of public available schema, standardized, or this is how your processing is?
It's like you have Windows executable files, you have like a reversing software to go through deep levels too. So say like from boundaries levels, it's similar like what you do for various analysis, malware analysis. You will see kind of tool like AutoHack or AutoHack.
There aren't really, there are people that are starting to collect CAN bus data, CAN bus commands for various cars. There isn't a really good repository of that data, so most of the people who are trying to make products to retrofit onto cars that control the CAN bus have to reverse engineer it themselves by testing it on a car and finding, going through, doing every little thing to send that data out, and then refining that data as it's reported through the car, and then once you found it, then you can move it.
Just like you were trying to find the security vulnerabilities of the browser or the Android the operating systems by using like a fuzzy reverse engineering, just try to guess what the people before to try that.
That's a trial and error.
Yeah. Well, finally, for example, you brought up pictures of about what database file format or certain like diagnostic tools. They might have headers with synthesized followed by reserved fields, not used for time being, also followed by segments. Each segment represent tables. So from table, they also have headers 1, 1, 2, 4, which means you can check the tables right here with meaning for encryption flag or Hummer record. So the Hummer record shows how the length of the table declines. So you know what the total looks like for the database.
So is this like the standard format?
No, it's just like different product, different protocols for different origin. So for example, you were saying, okay, I have idea about the tables, right? So here is the binaries from very beginning. So I can check, okay, the first 40 hash bytes is speed. So I can see speed unit here. So the next field is like 4 bytes here. So I can check from 0, 0, 0, 0. So followed by next 80. So here, right here, and right here. Okay, so we can follow the chart. You're based on the flags, all of those binary files. We'll show you what the ID index, the start position, and position of command line. It's very tedious work. It happened for like security research, and they has been most of the time doing reverse engineering a lot of the malware. Use similar approach. So how we control car we're OE. Here OE connects to the general gateways. So we send like commands. So gateway will parse the ID and send the message to the corresponding modules. So each module will check the K message. If the K message is valid, you are doing the corresponding behavior. So in this way, we can kind of hijack or control cars. So here in the example, so we develop mobile apps just like this UI. The good thing is you have no idea, you don't need any background about the car. So you just, for example, define, upload and download, install on your mobile phones, and you spend $15 online to purchase a VD box. You can get anywhere just from online companies. What I'm trying to say is the car hacking threshold is very low, so you can use the both stuff and do some like the hacker things. So each button for different one attack scenario. So kill engine, so when you drive car very slow, you just stop the engine. Even if you have a car, you have the key inside, you just sit behind the wheel. Also, you can unlock the trunk and the hole. Also, the meters lock and unlock the door. And you can also manually improve your CAD map if you're very familiar with the CAD message. You can give feedback from the car, from OE, will show you it's successful or it's an error code.
What is the typically say if I'm waiting 70 stop?
Yeah, so like if you drive the car very slow, I'll show the level on next page. Yeah, this is the demo. I use the Mission Possible soundtrack just for fun, not for promotion. So you say the truck order, click the button. The next is unlock and unlock door. It's a light. Even if the car is not moving. This is angry. This is not angry. This is not. So, how do you say?
All those attacks, they will work on one specific manufacturer, right?
Yeah,
They're-
yeah, because this is work for Camry and Hyundai Sonata. Yeah, guys bigger they did is for Escape and Prius. But different car models have different private products unique innovation, but some command the same. Some
Okay. And I apologize for being a little bit late, but the device that's attached gives you a Bluetooth tie-in to the car's network. Is that right?
We're using the Wi-Fi.
Wi-Fi.
Yeah, like we can stand just outside the car. We don't need to sit inside the car, so we can control.
Okay.
Yeah, but you can also use 2G or 3G will be an even long distance. You can maybe control the car like 1 mile or 2 miles away. But in that case, the box will be more expensive, like $40. But this one only like $10 or $15. So I mean, how are you gonna send a message? Because for example, the autometers, the only very simple analyze begin with 7C0. For example, this 2 lines you can end with FF. If the result is 140, 80, that means what the autometers values will show from the panel. So they're also like a hard code obviously inside this command. The next one is how we go to RPM. This ECU called condition read will take off this message. In the same way as RPM is 0, 1,000, 2,000 to 7,000. This depends on the value of this one. This for the tank. Empty warning also send this message. It looks very simple. For the horn, it's 2 kind of horn. One is a regular one, and one is a secure one. It might have difference with this. In one is for 640 bytes is 4, and one is number is. And this one, NVQ engines, it's 1 to 8. You can check it's 1 to 3. But you don't want to pick all that at one time, just use the 0F.
You're killing each individual cylinder.
Yeah. So this was Trump and we will this more lock and lock. Open Trump. For the NAND. 150 and 14. So here, because they're different, just like you asked, they're different vendors try different language. We compare Camry and Sonata because for the same behavior, have different messages. So, Rocket, we are trying with this starting for some.
The automakers thus far have tended to write the CAN-bus codes in a consistent way for each one, right? So you don't see a lot of difference. So a command for unlocking the door on a BMW might be the same on whether it's a 3 series or 5 series sensors, but it's probably different than a command for unlocking the door on Mercedes because they wrote something different. And those databases are being reverse engineered by various people for various reasons, and they're slowly becoming available online. You can search for them, and sometimes you find, especially like the auto enthusiast groups like the BMW site, guys try to figure out how to hack their instrument cluster and their head unit so they can do things with it that the designers never. And those commands get discovered and published.
Like a lot of, if you watch like a lot of movies and all that sort of stuff, not movies, but a lot of TV shows, they talk about like modifying cars and all that sort of stuff. They say, oh, the guy changed his ECU and now it gets even more power. So what does that mean? You actually unlock?
Well, in that case, the tuners do mods on ECUs. The ECU is usually meant to be the engine control unit. That term is also sometimes used for electronic control unit. So when they say ECU, they usually mean the engine. The engine currently is got a program in it, software program, that runs the fuel injectors, changes the ignition timing, looks at the mass airflow sensors, all the sensors in the engine. It's currently set up so that the car maker meets the federal emissions and fuel economy requirements under a wide range of conditions. Tuners sometimes find ways to, increase the duration of the fuel injector cycle, give it a little more fuel with a little less air, or give it a little more timing advance. Change it in little ways that, under some conditions, give it a little more power. It might be stressing the engine more than the manufacturer likes. But some actually bless that. In fact, most of the big 3 in the U.S. now provide tuners, like software developers that are signed up on their program. You buy a developer kit from them, you'll get access to some range of that data, and you can develop your own chip. So the guys that do that are hacking on laptops, trying to change the fuel air ratio and changing the injector times and changing the advance, and that's what they're doing.
And did you guys also discover attack scenarios which are only using the generic OBD functionality, or are all those attack scenarios just open because the manufacturers put extra functionality in the interface?
Well, I think thus far they have hacked the instruments, they've hacked the engine, they've hacked the things like the door locks and all that stuff like that. You can hack the other stuff, but then you do need access to get you into the codes that you need to monitor, hack other things. So it's all hackable, and if you reverse engineer an enhanced diagnostic tool, you'll probably get access to a lot more codes.
By regular, you're taking that sometimes to reverse one model, but in my understanding, they probably a lot of people already done this, so they have accumulated a lot of that. They are available, but when we do this using regular reverse engineering, it takes some time for one.
Yeah, it's a lengthy process to do it. For example, there's a tuner, forgetting their name. They're based in the Detroit area, and they tune Ford cars. So they've come out with actual chips and a small device that you can program to some extent yourself. It took them like a year and a half working with Ford to develop a chip that could be tuned for various levels of increasing power, that would work with different octanes of fuel, and validate it. So it's actually a legitimate hack. The hack you could buy and put on your car. You had an EcoBoost tuning turbo. You can get 20-25% more power.
what's the name that that's sold off?
What's that?
What's the name of the product that like that's sold under?
That I'll think of it. It's the name of the company is the name of one of the towns in Michigan. It's not Dearborn Engineering, but it's another name. But yeah, there's things like that available. And there are companies that do legitimate business in hacking into car systems. And there are some companies that are hacking in and they find they have to adopt and adjust their work because maybe their codes change and they can't get access to the door locks anymore. They can't read the product code, things like that. So it's a brave new world.
So for the
So these commands are injected through the twisted pair, or you can inject through OBD?
The hacking,
Yeah, like door open.
well, again, the wireless hacking is easiest done with a device like that plugged into the database. So if you have a device like that you're using for some other applications, other people can hack into it if they it's there. If you don't have that, you either have to go in with a wired connection on a laptop or extend to it, or one of these.
It's probably three factors. One is like OBD physical connected by the technician and also a laptop, you can do some like commands. Another way is this example by Wi-Fi apps. The third one, if you have SIM card bag, you have control from cloud, so you can send the command into the SIM card. SIM card will send text message into OBD, the door open. It's quite commonly used by the car rental, like P2P car rental, and the car owner and the car rental don't need to meet face to face, just leave the key inside the apps.
There also have been documented hacks in the cars with a CD-ROM that went into your unit, because some cars accept programming updates through that, and somebody figured out how to put some bad code into that. Another way that's been documented where somebody hacked is all cars now are required to have tire pressure monitoring systems. Each of those is a sensor inside your wheel. It's an RF device, and you did a denial of service attack on the tire pressure monitor where they kept sending low tire pressure signals from everything and overloaded the CAN bus and nothing else.
Would you expect a car to be infected with malware?
What's that?
Would you expect a car to be infected with malware?
It could be. It could happen very, very soon.
All that snow crash or something like that?
Perhaps. I mean, it would have to come in at some point. Now, it could come in at a dealership, took it in for servicing, and maybe they did an update, and the computer they updated it from had some sort
Or
of
a malicious CD-ROM put in stereo?
Yeah, well, because there was a delivery feature in that particular car, and I don't know what the car was, but that they would actually upload software updates through the head unit for the CD. And like in my car, I can do get my Ford Touch system, and it has an SD card slot, and you do updates to that system by, or it has a USB port, sorry, you download the firmware update on your laptop onto a memory stick and you plug it in.
So you wouldn't play my band's demo on your car stereo?
Yeah. Well, it depends, yeah, how good you think.
So I went to this QNX seminar, and the guys claimed that one of the reasons most of the major infotainment systems they're still based on QNX is that QNX is better security structure. It has a microkernel, and then it has the Windows manager, and everything is outside the kernel. So if your app misbehaves, try to cause a buffer overflow or anything, QNX just kills it and then restart it. Whereas,
that could be true. Certainly there's a lot more malware for Windows, and Windows Mobile never really took off in cars. The car makers didn't embrace it very heavily. Like I said, QNX is the largest operating system now, and there may be part of that might be more security, but it's still somewhat vulnerable through other avenues getting into the car that may not have to come in to the QNX device at all, just go directly to the camera. QNX is only on the head.
Is there any plan for this car makers to put security cameras?
They got to be thinking about it. They've been attending some of these conferences, like you've been to. They go to Black Hat and whatnot. And now that published, valid hacks have been accomplished, documented, and people are getting concerned about it. Even the federal government is looking into it. After doing another presentation at another meetup, I got through an attorney who attended. I got a call from a company in DC that consults for the Department of Homeland Security, and they're interested in this whole subject as part of their concerns about machine-to-machine network hacking. And to them, cars are just another extension of the end-to-end network, and if malware can get into an end-to-end network, can get into cars, and a bad person with bad intentions can create huge havoc if they figure out how to shut down 30% of the cars.
Second question is there any only read-only OBD code? Read-only OBD device?
Read-only?
Yes.
No, you can actually program the ECU through the OBD port on some
They have some like OBD routes by using privacy protocols. I mean, if you want to inject some like you have to follow the but then like the more expensive box they have still like $100, they might have their own private protocols. But in my next example, we still be able to crack those protocols and inject into the commands into the box. The box will be our show in the next time. We still have 15 slots. So it's an interesting one because before the June in Beijing, the Tesla, because of this conference organizer to Tesla on site and ask a call for participants to hack those ones. It turned out that there are several groups that have a high score. One score can give like $1 Chinese dollar, so they probably get like $2,000. I mean, this team from the university in China and their advisor spent a lot of time on the car security, so no wonder they can work out much higher score than other teams. All this come out related to the key that works in back. So the some device can call the whole like frequencies. They can like send the speed signal through RF into the car. Then the door will be open. So they also follow this idea. This one show they figure out the frequency of the key and they can navigate with this frequency, keep the door open, keep the sunroof open, but they can also move the car. Otherwise, a Tesla will give like $10,000 for the price. There are also like a few people from Tesla. All the team attend those events, try to looking for some talent for the recruiting. Yeah, I mean, that night Tesla just offered us like 3 very delicious dinner in Beijing. Yeah, and a lot of money. So how to defend attacks? There's 3 ways. One is authentication, but we need help from the car manufacturer with long way to go. So we do not depend on. Also encryption. And ECU very limited computer capacities and also memories very hard for encryption. So after the time being, all the commands through the box into the command portal of plain text. So we go for the third one. We build out our canvas firewall, and we try to drop malicious messaging into the car. Here's the manual products. So we spent like almost 2 months on this one. Looks it's ugly, but it is just for the demo. So we design the software first, then we design the hardware device. And finally, we do some programming into the MCU. So initially they have 2 bins, one is female port and then is a male port. So for example, if you have device you can plug into. So this will go to OBD. So all the messages coming through the OBD port, we have monitor of the traffic. It was inline transaction. Whenever we find the malicious, we just stop. And for the commercial one, we plan to just make smaller and beautiful. Right now, we want just like detail. So this functionality goes on our firewall. We have two bits, female and male, so we also can monitor all the messages. This MCU, they have a different functionality. First one will be like a regular one, get data from car. For example, we have mobile apps. We want to monitor, let's say, the keys, the speeding, do some texting or phone when they're driving. And we also do message parsing. We can parsing the ID and where like the comments. Then we also have predefined frequency threshold because the threshold means how many messages we receive per minute. If there are a lot of messages injected into the port, it could be like a damage of service. So we can detect some anomalies. We can also send an alert to the mobile apps. The app will go to the cloud. So how the management portal will say, okay, any problem with some car. For the communication module, could be Bluetooth or Wi-Fi or 3G or 2G, depending on how many you want to use it. This device. And I mean, the good thing is it's very low false rate because we just depending on the certain models and OBD, the messages, they're very low false quality and it's inline protection. And we also support like regular and standard message format. And we can work with mobile apps, so we can update the threshold values and there are some other updates into the box. So whenever we have new like signatures, we can update through our mobile app into Flash. The Flash we're working with MCU. In the drawback is we need to depend on OBD and car models. We do a car model, but if you like say car manufacturer agree to work together, we can provide more information about the message. So here's another device, the Charlie's and Chris, the team, they're going to present next week in the Red Hat or desktop. This is called, they spend like $150 on this board. I mean, from the press release, there's a picture, so I just guess that probably this one is for MCU. They also have the algorithm for anomaly detection. I mean, they focus on anomaly detection using one maze to self-learning the pattern. If the pattern was different from normal patterns, they will shut down the board. So whenever you want to send any valid or deny or malicious, they all shut down unless you restart the car. So this one is anomaly detection. So there's nothing to do with the OBD, and they also can generate for different models. The drawback is for anomaly detection. They usually have very high false quality. So they're passive mode, which means they can only monitor, but they cannot block in real time. So if you are interested, you can go to that.
So I have a question. So when do we actually say car is moving? What is the necessity for a person to send CAN commands over the board? What scenarios would require that?
You need the car to move.
Yes.
You mean, why would you send a command to a moving car to
Yes.
stop if you were a bad person?
No, not a bad person. But I can say, I can disable directly.
Well, I think
Taking commands if I'm moving.
this raises the question. We've actually discussed this issue. I mean, it's a concern, but for most people today, it's of no concern because it hasn't happened to you yet. But as, let's say, you become a user of Uber or a rental car company that uses now an app to access the car. Well, someone gains access to that coding and can go in easily to the campus and steal the car with their phone. Then it becomes of more concern. there's actually a lot of research going on. The police would like a way to be able to stop selective cars. If they're chasing one, they can stop a high-speed chase. They can no way they can send a signal to a particular car to shut down. So there are cases where it makes sense for varieties of market reasons or various reasons. It's probably not a general consumer security concern.
100%. Yeah. All these trying to block, look at firewall protection. A simple way of this, looking at the necessity of me actually requiring to send commands. If I eliminate that, say then I can make it even ridiculous. Then yeah, they can read all the data they want, but they can't handle the car. And when I actually need to input the commands, I may have some other key or some simple physical compounds that can actually make the commands work.
The problem is that there are like half million drivers that have those box specific plug into the OOBD for all the time, right? Because for the insurance companies, they have like UBI. So if you plug this one, you are a good driver. They collect all the driver profile, review where good premiums for the car insurance. You have to put on all the time. Another is like car rental for the rent for the car. They have to put on this so the monitor will show where the car is. So it's not like driver who want into the but what if like the cloud server was hacked? So from the server, you can send all the messages to every cars within this OBD boxes. So we need some way to figure out what happened. Any securities could be embedded into the box.
So the use case is mostly rental cars.
The rental car insurance also could be like black box.
Insurance is only reading why do they need to send commands?
But what is like insurance data has to be collect data, but they might like on Star, right? You can open the door, the Star will send a message or a car.
There's a market for high-risk consumers who get high-risk car loans, and when they want to repossess those cars, they have boxes now that run with GPS that they can find who they can shut them off. And they can do it with a system like this with less cost associated with it.
So again, the market would be split into two different categories.
Well, there's multiple things. As I mentioned earlier, one thing is keeping unwanted data out of your car. Right? You don't want your car to be attacked by some hacker attack or a data collection attack. If you pull into a parking garage and somebody's put a reader there that's reading data in your car because you've got a wireless interface, they're capturing data and you can resell it, use it some other way, figure out if you're home or not, know where your address was, your car, your VIN number, there's more stuff out there. The other thing is then protecting your own privacy with the apps that you bring into your car. You want to know that those apps are not leaking your personal data out in a way that's being used incorrectly. California has a new law about opting out privacy, and so that may help. But the app portion of this box, so you got an app and you've got a firewall, the app portion can help you keep monitor on what your apps in your car are leaking out to other sources. So you don't know that today. You should get an app that like that to you. And the other thing that I just read this morning is that there's a move now to that if you're pulled over in a traffic stop, that all the data on your phone is fair game, especially as it relates to how you're driving.
So with the anomaly detection method, are they basically monitoring like the bus bandwidth, and if the bandwidth utilization goes too high or they see a message that they don't recognize, is that what anomaly means? Are there other types of anomalies that they can detect?
Maybe 1 minute to learn traffic, like traffic frequencies and what the traffic patterns. It's like normally intrusion detection on networking traffic. Because normally it's very generic, but they have issues with first mode.
But with 1 minute or even 1 hour, I mean, there some messages that only come, like for example, when you're driving in extreme conditions, right? You might get the stability control, for example, only comes when you're driving like crazy. So you're not going to see that message during the learning process. So how did they overcome those type of things?
So they set up the 1 minute time window. They couldn't be changed.
Okay.
So when car is off, the ignition is off, can the attack happen if the port is still active?
It can wake up in a sense, but it's normally off.
Yeah, the OBD power still have the power from the battery.
But
If the car is stopped, the OBD will still have it.
Various things in the car wake up periodically and check.
We brought up very interesting point. How is this going to be integrated into automated cars, like cars that doesn't require a driver?
Well, that's a good question. Obviously, they're going to have to be very secure, and that's one of the reasons the security people in the NSA was interested, because if there is an easy way for people to start hacking cars, they don't want to start letting lots of automated cars go everywhere until they know if they're absolutely secure. So there's an issue being investigated as we speak.
As of today, how many cars, or in terms of percentage, what's the percentage of cars that has been hacked?
Oh, it's very small. Very small. No one even thought they could be hacked until a year ago. And as someone who's worked in the industry, I worked on the SAE tire pressure monitoring system standards back in the 80s, I guess it was. We were writing a spec for this wireless system that was going to read tire pressures all the time. All of us that came from many different companies that were on that committee never once thought about a hacker coming into that system and doing a denial of service attack on it to disrupt something going on in the car. The entire auto industry just never thought this was going to become a problem. So nothing was done about it. We're just starting to think about it.
I mean, the car infection is not like a computer. If a computer will infect the virus, we do all the format parts for car, like a human being life. We can think like in the car record, like what people like car manufacturer we call the millions car. It could like 1 out of 1 million could happen, but for the car hacking, they simple because we take a lot of money from the results for the car manufacturer. If something really happened.
In your estimation, what percentage of cars on the road today are potentially hackable?
I'd say all of them are testables right now.
But not all of them are new enough to be hackable.
Well, that's true. Anything that has an OBD2 port can be hacked to some degree. So anything since 96.
It's just like you have the computer, you don't have any antivirus installed. So, I mean, you just say, okay, my computer is not affected, but sometimes, when like the virus just installed and you were just stealing your data and something. I mean, I'm trying to show that attack threshold is very low. For example, people can easily to develop such mobile apps. You can purchase on this box. For example, there are like over 100 factories in China producing such box. There are like say like 500,000 people with this box on the car. And the threshold is very low. You can ask the sweet kitties. You can use the similar way to hack. But I mean, it just a matter of time. But we need to prepare. Security always go moving forward before the products.
It was like PCs. I mean, the first days of PCs, there were no hacking attacks. There was no antivirus software. There was no malware, stuff. And pretty soon, people figured out how to attack them and send malware and send ads and do pop-up ads. And it's the same kind of thing here. It's going to evolve. And it's better to protect it sooner rather than later.
So the AutoHack vulnerability of the 2 port, there's the Wi-Fi standards in proposed. So can you speak to how that will affect, hacking for ODP2?
Well, I'm aware I've been to a number of presentations within the past 6 months where the companies who make CAN bus chips, because the CAN bus is integrated on these modules with a standard CAN bus interface, they're all working on security protocols to add layers of security to CAN bus communication. Now, that will probably help, and of course, increasing overall access to the car. But you still have this situation where you produce a car, it has to be serviced, and by law, in at least one state now, and others are probably going to do the same, is that the auto manufacturers have to make the data available to independent service facilities to be able to service all cars. It's not like they can control that channel completely on their own. So there has to be a process for vetting and allowing certain people to access car networks that are authorized to do so. That's a whole big issue that hasn't really been defined and structured yet, but that'll probably have to happen.
So is it like other chip makers, are they doing the thing consortium or something?
No, each one is looking at the problem pretty much on their own. The CAN bus itself was a consortium. It was developed initially by Bosch and Intel and I think one or two of the German car companies. But they didn't design any security measures into it. And I think now, since it's really a chip maker's business, they make all the CAN bus chips and everybody just buys them. It's not important. Probably going to be up to them to integrate some level of better security at the chip level.
So it has to be on the chip level?
Well, no, you can add external things. This might be a stopgap measure for some time until more secure networks are used. But it's an evolving phenomenon, just like internet security is. You got to stay one step ahead.
So you said earlier that different car makers they use different languages to write the data.
Well, not so much they use different languages, but they use different commands, different data commands to mean, engine fire cylinder 1, unlock door, and that sort of thing. That's not a standard. They write that code themselves. They assign those variables to arbitrary. But they all tend to use processors with known languages, usually highly. There's a protocol called FlexRay that more advanced engine controls use. That's kind of a network / operating system protocol.
Okay, this one is just in the picture, and we found some security vulnerabilities. We use Wireshark to just monitor the traffic, then we can figure out their privacy communication protocols marked in this show. Then we can, according to this protocol format, we can send some commands into the port. So this is send data format. If you send data follow by the format, you will just inject this message. So here are the videos. We plug this one into OBD port, and we run some scripts, like physical connecting, like laptop. Just be careful. Just take a look at this area. We run the script, and we take a while. This message will change. So, just like I say, every manufacturer has different protocol. The matter is how robust the protocol is.
You were able to access that from external, from the outside of the car? That the device you attached?
Yeah. So you just attach the box, and then you can run scripts.
You didn't need to get into the engine compartment or anything?
No, just through the port.
Yeah, but the port is in the inside.
Yeah.
Is it Bluetooth or?
It should be Wi-Fi. It's like $30. It should be Wi-Fi. It's not Bluetooth.
It is below your steering wheel.
The question is, what kind of security do they have on the Wi-Fi?
it was an app, right? It was an app that had a dongle. So you could plug that in your car, and then with that app, you could see parameters about your car, and see what your car's doing. But they hacked the security PIN code for the app because it was so poorly designed.
So this is their protocol beginning with 5.5. So we just limit the 5.5 in our command lines. Then we inject our commands with one squeeze. It is followed this protocol format. So the box will see the value. So we forward to the corresponding flow to see.
So see if I understand this correctly. So we're saying that anybody who has purchased that little box and plugged into their car, as you're walking by on the street, you will have a way of deciding.
Yeah, it's possible. So we actually like at least 6 out of 10 box from Metro have similar or the same vulnerabilities. We also cannot copycat. So this current is because even the attack we are now seeing on real time, but it's the current company is negotiating with us. They try to ask me to have any vulnerability into their business model because they offer the electrical smart key, actually mobile apps, try to open the car doors, and there's a key inside. If I rent a car, I got application with the company, so I can drive the car back and leave it. When I took the car back to the same place. So we found there's some problems. First of all, we can upload unlimited picture into the cloud to jam the communication channels. So the server cannot send any message to the whole rented car. Another thing, I can easily change the password if I only know the user's mobile phone. If I know your mobile phone, I can change the password, so you have no access to the car, but me. Someone, they're very weak authentication and encryption, so I can even get a key from that. And right now we're testing. We ask them to send me, their box. We do some penetration testing using their car. We try to say if we can, kind of steal their cars without their awareness. It will happen because even in attack, but the car rentals have those requirements to make sure their products is secure. So the total solution is that we need OBD firewall to monitor all the command inject the car, but we also need to make it secure on the cloud, how to get data. And in near futures, there are a lot of more auto apps by using like Android Auto or like CarPlay interface offered by Apple and Google. So we need like audit program on this one to make sure they are not taking leakage, they are not safe driving, they are not sending any command into OBD4. So even if we are now safe for time being, but I'm confident we're safe for the next 6 months or within 1 year, a lot of tens of thousands of apps will be on the market. So here are the summaries. So here's the emerging market, but we need like secure and for the fast pace, even faster than mobile security. And right now, the manufacturer is not ready for such hacks, even if it's trying to keep silence. And so that's why if you have any interest in where you work at, we can work together for better solution here in our
Thank you. Any further questions? So when you say partners, what is that? Would you like to invest? Would you like to invest the right code? You hack? You want to
car rentals?
It's a startup, and it's getting a lot of interest, especially since car people are starting to see it. And so we're trying to move it forward as a startup, bootstrap as much as possible right now. But any of you have interest you think would be mutually beneficial, please talk.
Just I actually our go to like a DevCon last week, and actually there are some like company from Japanese. They're interested to talk about this topic, and also career people they like to focus on career structure on this.
So we'll be at a lot of conferences and trade shows. SEMA, CES.
Where are you guys based?
Santa Clara.
Where?
Santa Clara.
Santa Clara.
Oh, okay. Thank you.
So you want to show how we're...
Yeah, if you ever put some hair out for a few minutes, I'll answer questions about the hacking hardware I wrote. Yeah, all of these are here.